All right, let's keep rolling with section R2. We'll wrap things up with part B, objectives 5 through 8. All right, so first objective we're going to jump into here are the laws of exponents. And just remember that an exponent is a shortcut for multiplying. So a cubed is a shortcut for saying a times a 3 times. All right, so just one thing, we do have the base. We have the exponent, the whole thing together is called the power, okay? And so on this one, here's the important pieces that we forget a lot of times, and we need to come back. Anything in the world to the 0 power is 1, right? Anything at all to the 0 power is 1. And then on this one, we don't want to really deal with negative exponents on this one. We're going to flip this over. A to the negative n is 1 over a to the n. A to the negative third is 1 over a cubed, right? And by the flip of that, 1 over a to the negative cubed, a negative cubed, negative 3, flips over to a cubed. You could write over 1 if you wanted to, but we don't really need that. We can just write a cubed. All right, so let's evaluate some expressions containing negative exponents. All right, so we see the negative, so first things first, we're going to flip it over. 1 over 4 cubed, and then we're going to simplify from there. 4 cubed, 4 times 4 is 16, times 4 again is 64. Y to the negative 6, just flip it over, 1 over y to the 6th. And on this one, if you have a fraction, this is like saying flip it over. So instead of 2/3 to the negative 2, it's 3 over 2 to the positive 2. Which turns into 9 over 4. All right, knowing that, you've got two problems to do, 75 and 95. All right, let's jump back in with some laws of exponents here. If we are multiplying the bases with different m and n exponents, we're just going to add them together. So a cubed times a to the 5th is a to the 8th. All right, if there's parentheses, we'll multiply here. So a cubed to the 5th turns into a to the 15th. All right, we get normal distribution properties of the n. That will go to both of them here. And remember, multiplication and division are reciprocals of each other. So whatever we can do with multiplying, division is going to be the opposite. Okay, all right, and remember, we can always flip it over 1 if we reverse it. Nice little trick there. All right, and then lastly, if you have the fraction, this was the problem we did before, that n can go to both the a and the b. All right, so we'll look at 5 quick problems here. 5 plus negative 2. 5 minus 2 is what we're looking at, so we're going to have x cubed. We're going to distribute this in. We're going to have x to the negative 8. Okay, which means 1 over x to the 8th. All right, now here's where people make the mistake. The answer to this is not 3x to the 4th. Okay, that 4 has to go in both places. 3 to the 4th, which is 81, x to the 4th. Be very, very careful there. That's a common mistake. All right, this 3 is going to go both places. 3 cubed is 27. And 5 cubed, anybody know it? 125. 27 1/25. All right, lastly, these are both negative, so they're going to switch places. We're going to get x to the 7th over x to the 3rd. You've got 2 problems to try, 77 and 87. All right, let's talk about square roots for our 6th objective. Square roots. A is non-negative. Remember, you cannot take square roots of a negative. The non-negative number b, such as b squared equals a, is the principal square root. Okay, principal meaning, just a reminder, remember square root of 25 is 5, or it could be negative 5, right? But 5 is the principal square root on this one. All right, and so we're going to go through some steps on this. Just remember that the square root of 0 is 0, And you can't square root negatives. Those are the big things. All right, let's take a look here. Square root of 49. Square root of 7 squared, right? I put that up there just so we remember that square root and the squaring cancel out. We're left with 7. What about fractions? We can treat this as 2 separate square roots and get 1 over 3. All right, and here's the same rule that we talked about in A. The square root and the squaring cancel, and it just leaves us with 5.2. All right, we'll take a look at, this is supposed to say using equation 2 here, which is this out of your textbook. All right, the square root of a squared is the absolute value of a. So right away we know that this is 4.5. This is not negative 4.5. The answer to this is not negative 4.5, it's 4.5, because once we square it, the negative's going to go away. And lastly here, the answer to this is going to be the absolute value of x. Got to put the absolute value around that because we don't know if x is negative. What if we found out later that x was negative 3? We don't want to write down negative 3 as our answer. We would want to write down positive 3. Okay, so don't forget that absolute value sign around x. All right, 83 is yours to try. Objective 7, using a calculator to evaluate exponents. So, exponents on a graphing calculator. Let me pause this real quick and see if we have TI-83 installed on here. Not sure if we do. We'll find out in 1 second. Nope. I'm up here in RB60 doing this, which we don't have the math software installed. So 3.45 to the 6th, I'm going to trust that you can plug that in on your calculator. The key you're looking for is probably a caret, depending on which calculator you have. So make sure you can plug 3.45 to the 6th in there, and once you can do that, you can also do problem 113. All right, lastly, let's talk about some scientific notation. All right, scientific notation. When a number has been written as the product of x, where x is between 1 and 10, times the power of 10, it is said to be written in scientific notation. Something like this, 5.86, right, that's between 1 and 10, times 10 to the, I don't know, 8th. How about that? Scientific notation. We want this number to be a single digit, though. So if we wrote 58.6 times 10 to the 7th, no good. That's not scientific notation. Single digit in front of the decimal. Okay? All right. Oh, and also, if we're between 0 and 1, scientific notation, here we can use negative, and we'll look at that a little bit. All right, so let's write these in scientific notation. I want the decimal after the first significant digit. We talked about significant digits in the R1 video. 3 is a significant digit. 0.4562 times 10 to the, how many places did we have to move it? 1, 2, 3, 4. If the number starts out as a big number, we want it to get bigger, so to the positive 4. Second one, 2.345 times 10 to the, we had to move our decimal place once. All right, now, scientific notation, 4.88 times 10 to the, we moved our decimal place once. But we want our number to go from 4.88 and get smaller by 1 place, so negative 1. All right, lastly, scientific notation. 6 is the first significant digit I see. 6.7 times 10. 1, 2, 3, 4, 5, 6 to the negative 6. 119 is yours to try. See if you can do scientific notation. And I believe that's it. Oh, nope. One more to do after that. So try 119. We've got one more problem to do. All right, changing from scientific notation to decimals. Let's go backwards here. Write each number as a decimal. 4. We want to add 6 decimal places. That's what this is saying. 1, 2. What do we do now? We need 4 more. We're going to add in zeros. 3, 4, 5, 6. Let's put our commas in. 4,250,000. All right, 1.2, I'm going to write down 1 and the 2, and I need to go this way, 3. So I needed to move once for the decimal, 2 more to put in 0. So it'd be 0.0012. Same thing here. This is 5.0, and negative means I'm going this way. Fill in another 0. So 0.05. 127 is yours to try. Once you finish up 127, you are done. Now, any questions? We'll go over in the class.